Stemmen reporting live for Premier Magazine from the EPCC in Edinburgh. And we just finished the HPC User Forum here, and the local organizer was Mark Parsons from EPCC. So I cannot say welcome because I'm actually at your office, but welcome to this interview. So yeah. Okay, so can you first tell a little bit about the HPC User Forum? Were you happy with that?
Yeah, I was really happy with the User Forum. I haven't been to that many user forums myself. I just started going a few years ago, and Steve Conway asked me to organise this one about a year ago, I think. And they're a nice number of people. I mean, I don't know. I think the last one I went to in Europe was in HLRS, so they tend to be 60 to 80 people, and I think we had a really nice balance of speakers today, you know, from around the world. It's just a nice number. People tend to speak quite openly at them, I think. It's good.
Yep. Yeah, so that's a nice event. Now we are at the EPCC, and I must say I've never been here because it's a rather new building, it seems to me. So
yeah, so you're in the Bayes Centre, named after Thomas Bayes, he of the Bayes theorem, and he was an Edinburgh student, that's why. But also, this building is a brand new building, opened last summer, and it's focused entirely on organisations in the university and the local area that do data science.
Okay.
And the big change for EPCC over the last few years is we're now very focused both on supercomputing, HPC, and data science. And we moved from quite old offices, about 3 or 4 miles away from here, moved down to here. We've got 150 seats here, so we've got about 100 EPCC staff here, and then I've got a big area for our MSc and PhD students, because we like having the students just embedded with us, so they have coffee with us, they just talk to us. It's a nice way of teaching and learning with them. It's good.
So and what's the current status of the center?
So we're the biggest we've ever been, to be quite honest. For a long time we were sort of 70, 80 people, and the university, I was deeply involved in writing something called the City Deal.
Yeah.
And the City Deal is money from central government, both the UK government and the Scottish government, and it's supposed to increase innovation in your local region. And this is the Edinburgh City region. And the bid we put in was for a huge investment focused on data-driven innovation. And this building and another 4 buildings around the university are all focused on data-driven innovation and working with the public, private sector and the third sector in terms of embedding that in the local economy.
And you're still operating one of the largest systems in, I think, in Europe or perhaps in the world?
So Archer, which is the current national system, is actually quite small and quite old now. So it's just coming to end of life. It'll be turned off in February 2020, and then Archer 2 will come in. Yeah. And it will be one of the big systems. It'll certainly be within the top 20, the top 500, I'd say. Yeah.
Okay, and that's the UK national supercomputer.
Yeah, exactly. That's the national HPC system for the UK. The predominant users of that are physical sciences users and environmental science users. And then we also run another national service called the Tesseract service for the DIRAC consortium, and that's focused on astronomy, particle physics, and those areas, cosmology. And then we run a series of, we've got a tier 2 service as well, which is mainly focused on industry, and a number of small services to go around that.
Yeah.
But the big investment recently actually isn't in HPC. As part of the City Deal, I got money to build a new data centre room, so 20 million for that. And then I've got another 90 million to build this data infrastructure over the next 10 years. So it's really good. It's long-term funding for capital equipment to support all the data activities that we'll have. I'm very happy about that.
Okay. Sounds good, yeah. So the different machines serve different user communities. So I assume, yeah.
I think we probably slightly accidentally, but it now obviously is a strategy. The UK has had a good model of effectively trying to create ramps towards different levels of computing. So there's a very long tail of researchers that need quite basic e-infrastructure support. And then there's definitely a group who sit on what we call in the UK sort of tier 2, who are definitely already accomplished HPC users, but they don't need a system with hundreds of thousands of cores.
Yeah.
So my tier 2 is 10,000 cores, or thereabouts, a bit more than that. And the average job size of that will be quite small jobs, 64, 128 cores. Whereas on the big national service Archer, we actively don't let users run small jobs like that.
Yeah.
We want to push them towards thousands of cores. But so I think you have to meet everybody's needs. You can't just meet needs at either point. In fact, there was an interesting thing today in Satoshi Matsuoka's talk, where he pointed out that the system that will be at Riken, the post-K, or Fugaku as we now call it, will be broadly used. So if you like, so a tier 2 user will still be happily invited onto the Fugaku system, as well as, of course, the really big capability users. And I think that's very attractive, because at the end of the day, these capabilities are going to be bought by governments, and they should be full of users.
Yeah.
Provided you operate them in a way that when a big user does come along wanting to use 300-400 million cores or whatever, or 2 million cores, whatever, you can make way for them and let them do those really big jobs as well.
Yeah. Okay, so talking about big machines, I mean, everybody, well, not everybody, but in our community, people are talking about exascale in the US and exascale in Europe and exascale in Japan and exascale in China. And I heard you talking about exascale in the UK.
Yeah.
So
if the UK has an interesting decision to make, or would have had, if Brexit hadn't happened, which would have been, would we properly join Euro HPC?
Yeah.
Or would we decide to do our own thing? Now, in some ways, the Brexit discussion has actually made that decision for us, because although it's not entirely true at the moment, because the funding for Euro HPC is through Horizon 2020, so the UK can still bid to these calls. Once this current set of calls is over, we won't be able to bid, because we will need to be a member of the joint undertaking for Euro HPC. And to be a member of the joint undertaking, you need to be either an associated state or a member state, and we're not going to be either.
Yeah.
So that then poses the question, what's the plan? What will the UK do? And we initially were having a discussion to take part in one of the Euro HPC consortia, and it was decided that we wouldn't do that. And then there's a piece of work that I've been doing, which has been looking at various options. You can either then, I think, I've been arguing very clearly with the government that we have to do something. Doing nothing is not an option, given that all of our competitor economies are going to be doing something. So then it comes down to, does the UK join Euro HPC somehow? Does it partner with another country, so America or Japan or even China? Does the UK build a system like it's happening in Europe, doing its own silicon, trying to do something really quite unusual? Or does the UK just buy a system from a vendor and benefit from all the other R&D that's going on around that? And at the moment, the case we're making for a system in the UK is basically the UK should buy a system.
Yeah. And buying a system means that you do that because you think it's important for scientific and industrial users to have access to such a kind of machine.
Well, I think, so I pose the question slightly differently. I think we know that supercomputing is important. We know that every car we drive and every plane we fly in needs supercomputing.
Yeah.
And we're at this kind of, in some way, exascale is completely artificial.
Yeah,
It's just a bigger computer.
Yeah.
And we have to, the supercomputing community throughout its history has set itself targets. The gigaflop era, the teraflop era, the petaflop era, and we're now going to the exaflop era. That's fine. That's how you make progress. But if the UK was simply to remain in the few tens of petaflops era, then we would be overtaken by all of the major economies that we compete with around the world.
Yeah.
So you have to think of exascale computing as a fantastic capability, but also make the case around the fact that you need to do it because your competitors are going to have access to it. And if you don't have access to it, then your products and services will be poorer.
Yeah. So are the typical, you could say, UK type applications, or that make the case for this type of machines, or is it the usual bunch?
So actually, funnily enough, I've been asked a very similar question recently by the government, which was, we say in the case that we've made that the UK is very strong in computational science.
Yeah.
And the query came back to that statement, justify it. And you suddenly think, well, where do I go to justify that statement? Now, in truth, the way to justify it is to look at the strength of UK science as a whole. And it is very strong if you look at the number of papers, number of citations. The UK is known worldwide for the amount of money that goes into UK science, really punching very, very high up the ladder. And we also know that so many of these different scientific disciplines simply cannot experiment in the physical world to prove their theories or the things that discover the things they're interested in. So we know that the fact that we're doing this broad amount of science and lots of it drives the fact that we're doing lots of computational science. Yeah. So the work that Prace did 5 or 6 years ago around what did the code sets look like that each of us was running in our centres. There are differences in emphasis, but actually the number of the codes across Europe that are used broadly are very, very similar, in fact. And I think that's true. I think there's a lot of overlap actually between us and the US, for instance. I think not so much with Japan, because Japan's got this history of investing long-term in particular applications that they are important to their country, like earthquake modelling, for example.
Yeah. Okay. So what's the current status? Is it's a kind of plan, or?
No, so where we are with this the project is a business case has been written for government that exists in draft form. It'll be submitted later this year, and then it goes through a series of stages where it'll be refined, questioned, maybe denied. I just don't know. Yeah. At the end of the day, it's a very, very large amount of money, and the government will have to take a decision. Yeah. So I just don't know what will happen. Yeah. But it's important that we've done the work to write the case.
Yeah. And if it happens, what is the kind of time steps and time scale?
So the time scale that's currently foreseen is the discussion in the case basically says if we wait until, say, 2026, in America they'll be going to 10 exaflop or more systems at that point. That's when they do their renewal of the 2021 systems. Yeah. We don't particularly want to try and do something in 2021 because actually I think these systems are going to be really tricky to deploy. There's going to be lots of work done around them because they really are phenomenal bits of IT engineering. But there's definitely a sweet spot around maybe late 22, early 23, where you can benefit from all the work that goes on in 21 and early 22 and deploy the technologies that have effectively been debugged by the really the people who are right at the front of the queue. Yeah. So that's the sort of time scale we're looking at them.
If you are preparing for such an exascale system, I mean, I suppose you cannot place it in your current data center, or can you?
Well, so, and this is one of the things that I think isn't talked about enough, that hosting these systems is going to be very difficult. And on the positive side, we're getting much more information about how big these systems will be. And I'm building a new computer room at the moment, and perhaps an exascale system will fit in it, or I can extend it a little bit. But it's not just about the room itself, it's about delivering the power and the cooling, and also worrying about the environment, because these systems are going to consume anywhere between 20 and 40 megawatts of electricity. That's a significant amount of carbon dioxide. So at the moment, I'm already started putting in place the 32 megawatt power supply. I've got 8 megawatts already. I'm adding another 24. But we're also looking at what do we do with all the hot water that comes out of the system. And we are entering a new phase of supercomputing because largely these computers are going to have water going into them that is hotter than it ever gets in Scotland. So I won't need to chill the water any longer. It's great. But then what do I do with this hot water? And one of the ideas that we're exploring is using that hot water to pump down into old mine workings under the data center and create a heat battery where the heat can then be taken out with heat pumps to heat buildings up to 5 or 10 miles away. So we're very excited by this. It's just at the planning stages at the moment. We're doing a big feasibility study. But I think we do need to think about these sort of things as the amount of power we're consuming in supercomputing goes up and up and up.
Yeah. So when I understand correctly, you just are collecting the heat that comes out of the computers, but you also have a way to store it. I mean, currently most people just heat buildings that are around, but then.
But if you have an underground river or a lake, or as we have old mine workings, you can heat the water in the mine workings up, and it gradually heats the rock up, and the rock is really good at storing that heat. So you can effectively create a heat battery.
Okay, sounds like.
It's very, and actually, I believe in the Netherlands, some people have been playing with these ideas as well.
Yeah, but we don't have that. Yeah, we have rock if you go deep enough. But, Okay, sounds like an interesting idea. So, thank you very much for this interview.
Pleasure.
For Premier Magazine, this was Atman reporting.